This video will teach you how to find the limiting and excess reactants, the mass of the product produced, and the mass of the excess reactant after the reaction using stoichiometry and molar equations. The limiting reactant is the reactant which is totally consumed by the chemical reaction while combining to make the product. In this problem, the product is iron. The limiting reactant is determined by finding out which of the two reactants, sodium and iron 3 oxide, produces less product. Start with the given amount of grams in the problem. In this case, 100 grams of sodium over 1. In order to transfer from grams to moles, a unit of measure, multiply by 1 mole over the molar mass of the element, in this case, sodium. The molar mass of an element is its mass per mole, the same as the mass given on periodic tables. Then, cross out grams of sodium on the top and bottom where they appear. Next, multiply by the molar ratio of iron elements to sodium elements. In this case, 2 to 6. Then, once again, cross out like terms, moles of sodium on the top and bottom. By doing so, it is easy to keep track of what the units represent. To complete this equation, multiply by the molar mass of iron over 1 mole of iron, in order to cancel out moles and transfer to grams. Next, cross out similar units. Multiply everything out on top and bottom and then divide. Your answer should be 80.97 grams of Fe. Repeat this process for the other element, in this case iron 3 oxide. Start with 100 grams of Fe2O3 over 1, the given in the equation. Once again, convert to moles by multiplying by 1 mole of iron 3 oxide over its molar mass. Fe2O3 is a compound though, which means finding its molar mass is more complex. Multiply the mass of iron by 2 and add it to the mass of oxygen times 3. This is done because there are 2 iron ions and 3 oxygen ions in this compound, as indicated by the subscript. Your answer should be 159.69 grams of Fe2O3. Now cross out like terms. Next, again multiply by the molar ratio of iron to Fe2O3, 2 to 1. Eliminate the moles of Fe2O3. Finally, multiply once again by the molar mass of iron over 1 mole of iron to cancel out moles and convert to grams. Your answer should be 69.94 grams of iron. Obviously, 69.94 is less than 80.97, so Fe2O3 is the limiting reactant in this chemical equation, which means automatically that Na is the excess reactant. Since we have already determined that Fe2O3 produces 69.94 grams of iron, that is the mass of the solid iron produced. Now, to find out how much of the excess reactant, sodium, was left over after the reaction was finished. In order to do so, we must start with the mass of iron we found using Fe2O3 over 1. We then convert to moles by multiplying by 1 mole of Fe over its molar mass. We then multiply by the molar ratio of Na to Fe, 1 to 2. Finally, we multiply by sodium's molar mass over 1 mole. Your answer should be 14.40 grams of Na. This is how much sodium was used up in the reaction. Subtract 14.40 from the initial 100 grams that was given in order to find out how much excess Na was left over. Your final answer should be 85.60 grams of Na.